Hallo, it's dumplet here. Here's an item on trigonometry. Given that 1 plus sine t times 1 plus cosine t is equal to 5 over 4, and 1 minus sine t times 1 minus cosine t can be expressed of this form, m over n minus square root of k. Find the value of m plus n plus k. Now take note, this is in simplest form, so m over n is in lowest terms, and then k is obviously a positive number here. Now we're asked to get the value of m plus n plus k. Credits to the Art of Problem Solving community for this item. As usual, pause this video if you'd like to give this item a try, but if you're done, let us dive into the solution. Now here in this question, we have obviously a nice symmetry. So in the first equation, we're given with the positive sines and cosines, and then here we have minus sines and cosines. So, well, to exploit this fact, I'm not really sure if this is like the first thing that you guys would think of, but I thought of expanding the left-hand side of both of these equations, because I realized that if I expand them out, I will get these two. So this will be the expansion of the first equation, and then I just wrote the m over n minus square root of k. Let's just call it a for now, because, well, I think it doesn't really matter. We just have to write a in terms of this format after we get the value of a. So let's just replace it by a for now so we can refer to it a little bit more easier. And there we go. So the second equation becomes that. Now, immediately we would see two familiar things. One, well, the sine t, cosine t, the product of a sine and a cosine, and the other one is the sum of the sine and cosine. Well, this one technically is, we can write it as negative of the expression sine t plus cosine t. And whenever we see sine t and cosine t together, we would expect kinda to use the Pythagorean identity, because we know that, well, sine squared t plus cosine squared t is equal to 1, and obviously if I expand the square of sine t plus cosine t, there's going to be this sine t cosine t term. So whenever we have something like similar to this one, we would kind of expect that maybe the Pythagorean identity will come into play, or maybe try to form like an equation using the sine t and the sine t plus cosine t and the sine t cosine t. So the sum of the sines and cosines and the product of the sines and cosines. All right, so we can kind of treat this as a system of equations. We're going to solve for the two things I just mentioned, the sum, sine t plus cosine t, and the product, sine t cosine t. And, well, because of the way that these two equations are given to us, if we add them, if we add the two equations, we're going to get 2 plus 2 sine t cosine t. That's going to be equal to 5/4 plus a. And that's pretty nice that we have this 2 sine t cosine t. We're going to see that in a while, but this is very nice because that is going to be the middle expression if I take the square of sine t plus cosine t. So if I square this, it is expected that there is going to be this term that's going to appear. So that's pretty nice. So if I solve for this value of 2 sine t cosine t, I will get that this would be equal to 5/4 plus a minus the 2. So a plus 5/4 minus 2, well, that's just simply equal to a minus 3/4. So this would be a minus 3/4. Now if I subtract the 2, on the other hand, if I subtract the 2, I will get 2 sine t plus 2 cosine t is equal to 5/4 minus a. So I can divide both sides by 2, and I'll get that sine t plus cosine t is going to be equal to this, 5/4 minus a divided by 2. And now we have an expression for sine t cosine t and 2 sine t cosine t in terms of a. And here is where the nice Pythagorean identity will come into play, because I am going to square sine t plus cosine t, and I would be able to have sine t cosine t in relation. Hallo, it's dumplet here. Identity, I guess, in a lot of the trigonometry manipulation questions. So hopefully you guys would memorize this one, because it is pretty common, because we have the sine squared t and the cosine squared t in red. That becomes the 1 over here, and now we can directly substitute the sine t cosine t, which is going to be this 5/4 minus alpha, 5/4 minus a divided by 2, as we've seen in the previous slide, and then the 2 sine t cosine t, which we acquired to be a minus 3/4. So now we just have an equation in terms of a, and I believe this will be a quadratic one because, well, there is this 5/4 minus a then squared. So apparently the thing in the beginning, the m divided by n minus the square root of k, it's going to appear as a quadratic, it's going to appear as a root to this quadratic equation. Now the square root of k kind of tells us that maybe the resulting quadratic the quadratic equation is not factorable, so we'll see about that. But anyways, at least we now have a nice relationship, a nice equation in terms of a. So I think what's left for us to do is kind of simplify this into a quadratic equation and try to solve for a. Now we can simplify stuff here. 1 plus a minus 3/4, that's just a plus 1/4. So we just have to kind of expand this one. Now we can multiply both sides by 4 because, well, the 2 squared in the denominator is 4. We can multiply both sides by 4. So essentially it's just 5/4 minus a squared, and that's going to be equal to 4a plus 1. And we just kind of have to expand this one. We're going to get 25 over 16 minus 5/2 a plus a squared. It's going to be equal to 4a plus 1. Now there is the 16 in the denominator. Let's multiply both sides by 16. So we're going to get 25. This term, after multiplying by 16, we're going to get minus 40a. And then this a squared will have a coefficient of 16. The 4a here becomes, the 4a plus 1 here becomes 64a, and then the plus 16. And if we put everything into one side, we're going to get 16a squared. The 64 moving to the other side. So negative 40 minus 64, that's going to give us negative 104a. And then the 25 minus 16, that's going to give us just positive 9. So this will be the quadratic that we are going to solve. And we have, well, as expected, this is not actually factorable, so we're going to use the quadratic formula here, as expected, because we have the m over n minus square root of k form to be given. So, all right, so substituting into the quadratic formula, negative b plus minus square root of b squared minus 4ac all over 2a. So all we have to do is just kind of simplify this one. Now 104 squared minus 4 times 16 times 9, that's a pretty big number, so you guys can work out the maths, but this is equal to 10,240. We kind of have to work on the prime factorization of this one, but it's pretty lucky here that we have a familiar number. We have the familiar 1024. That's actually 2 raised to 10, so that's a familiar power of 2. So that's 2 raised to 10. So this number apparently is just 2 raised to 10 times a 10. Well, 2 raised to 10 is a perfect square, so that kind of works for us. So 104 plus minus the square root of 2 raised to 10 times 10. So that's going to become 32, because that's 2 raised to 5, out of the square root, and then just 10 in the middle, inside the square root, and divided by 32. So that's the possible values for a. And let's write it in the format m over n minus square root k. So apparently we're going to disregard the negative root. We're going to see in a while why. But so it essentially m over n becomes 104 divided by 32. Both of these numbers are divisible by 8. So both of these numbers are divisible by 8. So 104 divided by 32 is 13 over 4. And then, well, the 32 square root of 10 divided by 32, the 32 actually cancels. So that just leaves the square root of 10 here. So apparently a would be equal to 13 over 4 minus square root of 10. But let's just try to consider why we cannot consider the positive one. So yes, indeed, this is going to be the answer. So the final answer to the question would just be equal to the m plus n plus k, so 13 plus 4 plus 10, which is equal to 27. That's the final answer indeed. But let's try to reason out why we cannot have a to be positive. So we cannot take the other root, 13 over 4 plus square root of 10. Now, we have sines and cosines, so kind of expected that we're going to do some bounding here to prove that this cannot be the answer. So let us try to approximate this value. 13 over 4, we know the value of this one. That's exactly 3.75 3.25. Now for the square root of 10, I'm pretty sure that's greater than 3. I'm just going to call it approximately 3.1. So approximately 3.1. So if I add them up, it's approximately 6.35. Probably not the most exact of values, but we can say it's approximately 6.35. And we can reason out by just finding the range, or like the bound of the left side. Now we know that sine t and cosine t, they're in the range -1 to 1. So if I want to make this as large as possible, well, 1, and then I can make sine t -1, cosine t -1, although no value of t is gonna make both of them to be -1 at the same time. But just for the bound, we just have 1, and then plus 1 for the negative sine t, and then another plus 1 for the minus cosine t, and the sine t, cosine t, again, technically this value is not attainable, but let's just, we're just talking about the bound anyway. Since sine t and cosine t, they're both less than or equal to 1, so I guess a nice upper bound here, we know that this one would be less than, so the left side would be less than 4,1, so that's less than 4, but if we're going to take the positive sign as the other root of the quadratic equation, that's going to be approximately 6.35, and that would be the reason why we can simply rule out the positive one, and we could conclude that it's the negative one. So anyways, so again, the final answer to this question would be 13 plus 4 plus 10, which would be equal to 27. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!